Chapter 2 of The Hurricane Hunters by Ivan Ray Tannehill. This LibriVox recording is in the public domain. Chapter 2 The Saddler's Apprentice. All violent gales or hurricanes are great whirlwinds. Redfield. In recent years, when men were first assigned to the alarming duty of flying into hurricanes, and they began to study the old records, one question bothered them very much. Why did it take so long to prove without doubt that these big tropical storms are whirlwinds? The main reason, of course, is the huge size of the wind circulation. The winds spiral in such a broad arc around the storm center that there is no noticeable change in the wind direction within a distance of many miles. It was like the curvature of the earth. Any circle around the full body of the earth is so enormous that it seems to be a straight line, and men were deceived for centuries into believing that the earth is flat. The crews of fast modern aircraft can fly through the main part of a hurricane in 2 or 3 hours at most, and they can immediately see changes of the wind as they go along. They have no reason to question it. In earlier times, there was no means of travel fast enough to get the facts in this way. Then, too, there was no means of sending messages fast enough to show what the wind was doing at the same instant in different parts of the storm. Also, the entire wind system was in motion, and if the various reports were not sent at the same time, the results, when they were charted, failed to make sense. This fact alone was the cause of much confusion, even as late as the first part of the 19th century. A definite answer to the whirlwind question came suddenly and unexpectedly in a most peculiar manner. In the summer of 1821, a young saddler was walking through the woods of central Connecticut with his inquiring mind on scientific matters of the day, when he discovered a strange fact that led to the first law of storms, and eventually made him the most illustrious of the hurricane hunters. His name was William Redfield. His ideas were first published in 1831, and together with the work of a few men who followed on his trail, were the mainstay of sailors in stormy weather for nearly 100 years. Hurricanes were not only extremely dangerous to the sailing ships of that day, but were becoming more destructive to the growing cities along the American coast. In the first quarter of the century, the population of the country doubled. In 1800, there were 5 million people. In spite of the War of 1812, which lasted for 3 years, and the temporary drop it caused in immigration, the population increased rapidly, mostly on and near the Atlantic coast. The United States began to take a place in the forefront of the world's commerce. But now and then a great storm from the tropics swept the entire seaboard and took a grievous toll of ships and men and harbor facilities. Up to that time, no one had learned enough about storms to give warnings in advance. There were no really useful rules to guide seamen around or out of a tropical storm. Weather prediction was not accepted as scientific work. Storm disasters were called acts of God, and the ways of the atmosphere were thought to be beyond human understanding. Occasionally, a mariner with an inquiring mind like Dampier came to the conclusion that tropical storms are huge whirlwinds which move from place to place. But none of these inquirers came up with any real proof. After 1800, the destruction from hurricanes grew steadily worse. The summer of 1815 was remarkable for furious storms all along the Atlantic coast. Newspapers were filled with the details of storm disasters and the destruction of life and property on shore and at sea. The crowning catastrophe was caused by a furious West Indian hurricane which struck New England on September 23 of that year. In the violence of its winds and the height of its tides, this storm was about equal to the New England hurricane of 1938. Although the country was far less populous in 1815, and the buildings, ships, and wharves subjected to its fury were much less numerous than in 1938, the destruction was so great, and the loss of life so heavy, that the newspapers did not have space enough to give all the details of the marine disasters in this instance. At Providence there was terrible destruction. the tide rose more than 7 feet above the highest stage previously recorded. 500 buildings were destroyed. The loss of life was never fully determined, but it was excessive. The same sort of tragic story came from New Bedford and other towns on the coast. Many buildings and a tremendous number of trees were blown down in the interior. The most treacherous feature of these big storms was their resemblance in the initial stages to the ordinary northeasters, which came at about the same time of year, late August or September, and blew fitfully for a day or two. They brought rain and high tides along the coast, and finally died out without much damage. Tropical storms, like the big one in 1815, began much the same way in New England, but suddenly become violent. Then, as now, they blew gustily from the northeast in the beginning, but went around the compass and ended with shattering onshore gales, which drove engulfing floods into the harbors. Everybody was caught off guard. This storm and another which came 6 years later in the same region set men to thinking seriously about ways to avoid these disasters. The violent hurricane of 1821 crossed Long Island and New England, leaving a path of destruction which lay somewhat to the westward of the hurricane path of 1815. Again, enormous numbers of trees were blown down, this time mostly in Connecticut, and here is where we come to the story of the saddler's apprentice. In September 1802, a sailor named Peleg Redfield of Middletown, Connecticut, died, leaving a widow and 6 children in very poor circumstances. The eldest child, William, 13 years of age, had attended common school and learned about reading, writing, and arithmetic, but when his father died, he had to be taken out of school. The next year William was apprenticed to a local saddle and harness maker. Boys as well as men worked long hours in those days, and William Redfield was no exception. After he had finished the day's work and had done the chores around the Redfield home, he had only a small part of his evening to himself. Even then he had a lot of discouragement, no books and no light to read by. The family could not afford candles. Nevertheless, William was so interested in science that he studied by the light of the wood fire, reading intently anything on scientific subjects that he could get his hands on. A year later, William's mother married a widower with 9 children of his own, and in 1806 the couple moved to Ohio, taking his 9 children and 5 of hers, but leaving William behind to look out for himself. He continued his study of science, but with no indication that he would eventually find some of the answers so vitally needed in the fight against hurricanes. His father, being a sailor, had told him about storms at sea, and the boy was unable to get this out of his mind. Fortunately, there was a well-educated physician in the village of Middleton, William Tully, who had a good library and made it available to young Redfield. The first book the physician handed to William was a very difficult volume on physics. The boy brought it back so soon the doctor thought he had been unable to understand it, but he was pleasantly surprised, for the lad had read it very thoroughly, and had come back for more technical works of the same. Soon William gained such an understanding of scientific matters that an intimate friendship with the physician developed. During this time, however, young Redfield felt an increasing urge to visit his mother. But she lived more than 700 miles from Middleton, and he had very little money. So in 1810 he walked all the way to Ohio. At that time Ohio had a very small population. It was less than 50,000 at the beginning of the century. The territory intervening between Ohio and Connecticut was pretty wild, with settlements only here and there. William followed primitive roads and trails, and at last reached the shores of Lake Erie, where Cleveland and other cities stand today. The next year he walked back to Connecticut. Redfield was now past 21. He had thought deeply of many things while he trudged those lonely trails. He had a vision of a great railway extending from Connecticut to the Mississippi River. Also, his mind kept running back over the stories of storms his father had told him. From his thoughts on this lonely journey, he devised and later executed a plan for a line of barges which operated between New York and Albany. But when he arrived at Middleton, he had no course for the time being except to go into business in his trade of saddler and harness maker. To supplement his poor income, he peddled merchandise in the region around Middleton, trudging through the woods and stopping in the villages here and there. The years went by, and he kept on studying science in his spare moments. And then, on the 3rd of September, 1821, the center of that vicious hurricane which crossed the eastern part of Connecticut brought its dire evidence to the very door of the man who was still trying to master the sciences in his spare moments. As Redfield trudged the countryside with his wares, he passed among hundreds of big trees felled by the furious winds. Near Middleton he found that the trees lay with their branches toward the northwest, and he remembered that the gale there had begun from the southeast. Less than 70 miles away he found the trees lying with their heads toward the southeast, and here the winds evidently had begun from the northwest. Making inquiries as he went along, Redfield learned the directions from which the wind had blown at various times during the storm. It became quite clear that the hurricane had been a huge whirlwind which had traveled across the country from south to north. He gathered a lot of evidence to prove it. But Redfield was now past 30 years of age. Because he had not gone very far in school, he did not see how he could undertake to demonstrate these facts about hurricanes to men of scientific learning. He kept turning the idea over in his mind at intervals as the months and years went by. In the meantime, he had become interested in navigation on the Hudson River, and had made a reputation as a marine engineer. By 1826 he was superintendent of a line of 40 or 50 barges and canal boats. But whenever he read of a bad storm on the coast, he thought about the hurricane of 1821 and the trees blown down in different directions by the opposing winds of a great whirling storm. In 1831, Professor Denison Olmsted of Yale College was traveling by boat from New York to New Haven. A stranger approached him and began talking about some papers the professor had published in the American Journal of Science. The stranger said his name was William C. Redfield. Actually, he had no middle name, but used the C for convenience, to keep from being confused with 2 other William Redfields in the area. In the course of the conversation, Redfield talked reservedly about his ideas regarding West Indian hurricanes. The professor was amazed, and urged him to publish his ideas in the American Journal of Science. Redfield, who was now 42 years old, began writing on the law of storms. He wrote well, and his ideas were clear and convincingly expressed. A long series of articles followed his first one in the American Journal of Science. During these years he became a famous hurricane hunter. He collected reports of West Indian hurricanes, as many as he could get from ships caught in storms and from other sources, and studied them at great length. He inspected the logbooks of vessels in port, interviewed many shipmasters, and corresponded with others. His urgent purpose was to devise a law of storms, and a set of rules to promote the safety of human life and property afloat on the oceans, and to afford some measure of protection for the inhabitants of cities and towns on the coast, subjected to destructive visits from these monsters of the tropics. After the death of Redfield in 1857, Professor Olmsted summarized his theory of storms as follows: that all violent gales or hurricanes are great whirlwinds, in which the wind blows in circuits around an axis, that the winds do not move in horizontal circles, but rather in spirals; that the direction of revolution is always uniform, being from right to left, or against the sun, on the north side of the equator, and from left to right, or with the sun, on the south side of the equator; that the velocity of rotation increases from the margin toward the center of the storm; that the whole body of air is, at the same time, moving forward in a path at a variable rate, but always with a velocity much less than its velocity of rotation; that in storms of a particular region, as the gales of the Atlantic or the typhoons of the China Sea, great uniformity exists with regard to the path pursued by these storms. Those of the Atlantic, for example, usually come from the equatorial regions east of the West India Islands, moving at first toward the northwest as far as the latitude of 30 degrees, and then gradually wheeling toward the northeast and following a path nearly parallel to the American coast until they are lost in mid-ocean. That their dimensions are sometimes very great, as much as 1,000 miles in diameter, while their paths over the ocean can sometimes be traced for 3,000 miles. These conclusions were in the main correct, but time has proved that there are many exceptions. At any rate, Redfield's papers became classics. He had demonstrated by collections of observations on shipboard that a tropical storm is an organized rotary wind system and not just a mass of air moving straight away at high velocities. It happened that in 1831, the same year in which Redfield's first paper appeared in the American Journal of Science, there was a terrible hurricane on the island of Barbados. Devastation was so great that the people on the island firmly believed the storm had been accompanied by an earthquake. More than 1,500 lives were lost. Property damage, considering values in that early day, was tremendous for a small island, estimated at more than $7 million. Barbados had suffered so much that England sent Colonel, afterward Brigadier General, William Reed of the Royal Engineers to superintend the reconstruction of the government buildings. He was appalled by what he saw. Reed examined the ruins and made inquiries of many people about the nature of the hurricane of 1831. He came to the conclusion that there had not been an earthquake, but all the damage had been caused by the wind and sea. One of the residents told Reed that when daybreak came, amidst the roar of the storm and the noise of falling roofs and walls, he had looked out over the harbor and saw a heaving body of lumber, shingles, staves, barrels, wreckage of all description, and vessels capsized or thrown on their beam ends in shallow water. The whole face of the country was laid waste. No sign of vegetation was seen except here and there patches of a sickly green. Trees were stripped of their boughs and foliage. The very surface of the ground looked as if fire had run through the land. Reed resolved to study hurricanes and see what he could do to reduce the consequent loss of life. He wanted to tell sailors how to keep out of these terrible storms, and he thought it might be possible to design buildings capable of withstanding the winds. Soon afterward, he saw Redfield's articles in the American Journal of Science. He wrote to the author, and they began a friendly correspondence, which continued until the latter's death. Neither Redfield nor Reed was actually the first to declare that the hurricane is a great whirlwind. Many others had suggested this before them, and in 1828 a German named H. W. Dove had confirmed it. But none of these had hunted up the data and talked and corresponded with hundreds of seamen to collect facts to prove their contentions, and none had presented the facts in a way that would serve as a law of storms for seamen. Following the lead of General Reed, an Englishman named Henry Piddington, on duty at Calcutta in India, became a great hurricane hunter in the middle of the 19th century. He collected information from every source, talked to seamen of all ranks from admiral down, and added a great deal to the law of storms. Because of the movement of violent winds around and in toward the hurricane center, he gave it the name cyclone, which means a coil of a snake. This is the reason why tropical storms are now called cyclones in the Bay of Bengal. Piddington, who became president of the Marine Courts of Inquiry at Calcutta, published numerous memoirs on the law of storms. Of all the accounts that he collected of experiences of seamen in tropical storms, the outstanding case, in his estimation, was that of the brig Charles Heddles, in a hurricane near Mauritius, a small island in the Indian Ocean east of Africa. Mauritius is south of the equator, where hurricane winds blow around the center in a clockwise direction, the opposite of the whirling motion of storms in the northern hemisphere. The Charles Heddles was originally in the slave trade, but at the time that she was caught in the hurricane was mostly being employed in the cattle trade between Mauritius and Madagascar. Only the fastest vessels were engaged in the cattle trade, and the Charles Heddles was an exceptionally good ship. Her master was a man named Fink, an able and highly respected seaman. On Friday, February 21, 1845, the Charles Heddles left Mauritius, and in the early morning of the 22nd ran into heavy weather, with wind and sea gradually increasing. It became squally, and the vessel was laboring greatly by midnight. On the 23rd it was worse, with a frightful sea, and the wind very high, accompanied by incessant rain. The sea swept over the decks, and the crew was frequently at the pumps. By this time Captain Fink had determined to keep the brig scudding before the wind, and run his chance of what might happen. The steady change of the wind around the compass as the day wore on made it impossible for him to estimate his position, but he was sure he had plenty of sea room. The crew was unable to clew up the topsail without risk of severe damage, so round and round they went. Wind force and weather were always about the same. There was a terrifying sea, the vessel constantly shipping water, which poured down the hatchways and cabin scuttle. The foretopsail blew away at 4 p.m., and they continued scudding under the bare poles, the wind's course changing steadily around the compass. By the 25th of February, the vessel was taking water through every seam, the crew was constantly at the pumps, or bailing water out of the cabins with buckets. All the provisions were wet. The seas broke clear over the ship. On the 26th, the hurricane winds continued without the least intermission. The ship was continually suffering damages, which had to be repaired as quickly as possible by the exhausted crew. The seas were monstrous, water going through the decks as though they were made of paper. Still, the ship was scudding and steadily changing course around the compass. By the 27th, the weather had improved, but the ship persisted in going round and round, veering and scudding before the wind. After all this trouble, Captain Fink succeeded in taking an observation, and found, to his surprise, that he was not far from port in Mauritius, from which he had set sail before the storm, almost a week earlier, and on the 28th he made for port there. From the log kept by Captain Fink, and the observations made on other ships caught in the same hurricane, Piddington laid down the track of the storm and the course of the Charles Heddle. Now it was clear that the ship had been carried round and round the storm center, at the same time going forward as the storm progressed. Its course at sea looked like a watch spring drawn out, a series of loops extending in an arc from the north to the west of Mauritius. Here was vivid and undeniable proof, from the experience of one ship, that hurricanes over the ocean are progressive whirlwinds, like the storm which Redfield had charted from trees blown down in Connecticut in 1821. Another fact was quite clear to Piddington, and he published it with the hope that all seafaring men would profit by it. He could see now why a ship could be carried hour after hour and day by day before the wind, apparently to great distances, and then be cast ashore near the very place where the ship took to sea. Inspired by this report of the Charles Heddles in the hurricane, Piddington suggested, for the first time in history, 1845, that ships be sent out to study hurricanes. He wrote, "Every man and every set of men who are pursuing the investigation of any great question are apt to overrate its importance, and perhaps I shall only excite a smile when I say that the day will yet come when ships will be sent out to investigate the nature and course of storms and hurricanes, as they are now sent out to reach the poles, or to survey pestilential coasts, or on any other scientific service." The prediction which Piddington put in italics was eventually verified, though nearly a century later. Nothing, indeed, can more clearly show, Piddington continued, how this may, with a well-appointed and managed vessel, be done in perfect safety, performed by mere chance by a fast-sailing colonial brig, manned only as a bullock-trader, but capitally officered, and developing for the seaman and meteorologist a view of what we may almost call the internal phenomena of winds and waves in a hurricane. But this was only the beginning. Learning the secrets of the hurricane proved to be far more difficult than Redfield, Reed, and Piddington had imagined. The world looked in amazement at the tremendous labors of a few men, who collected enormous quantities of reports, interviews, and observations from mariners, and tried to put the bits together, but there was a prevailing suspicion that the real facts were locked in the minds of men who had gone to their doom in ships sunk in the centers of these awful storms, and the lucky ones who came back had seen only a part of their ultimate terrors. In these days of relatively safe navigation at the middle of the 20th century, our minds are scarcely able to grasp the seriousness of this scourge of tropical and subtropical seas which destroyed so many ships and drove busy men, working long hours for a living, to such tremendous labors at night and at odd times to learn the truth. We may get some light from the stories of desperate sailors who, by some strange fate, were thrown exhausted on the rocks that finally claimed the broken remains of once proud vessels of trade and war. End of chapter 2.